Find all asymptotes, intercepts, and holes and use them to graph the following function. First, we'll start with domain. To find domain, we set the denominator equal to 0 and solve. X squared minus 4 equals 0. We'll add 4 to both sides. Take the square root of both sides. And we see that x is equal to plus or minus 2. Or we can actually say not equal to, since those are restrictions. Writing the domain as a set would be all x such that x is not negative 2 and x is not positive 2. If we wanted to write the domain as an interval, we would look at negative infinity to negative 2, union negative 2 to positive 2, union 2 to infinity. To find vertical asymptotes, we start by making sure the function does not reduce. And right away, hopefully we'll recognize that it does not. The top does not factor. The bottom is a difference of squares. And we can see nothing reduces. So we now, again, set the denominator equal to 0, which we've already done earlier. We get x equals 2 and x equals negative 2 for the two vertical asymptotes. To find holes in the graph, we question whether or not a factor reduced, and it did not, so we don't have any holes. Horizontal asymptotes, we compare degrees. Notice the top degree is 1 and the bottom is 2. If the top degree is ever smaller than the bottom, then the horizontal asymptote is automatically the x-axis. If you have a horizontal asymptote, we do not have an oblique. To find x-intercepts, we set the numerator equal to 0. Negative 3x equals 0. Divide by negative 3 on both sides, and we get that x equals 0. So the x-intercept is simply the origin. That automatically makes the y-intercept the origin because x is 0. Let's put all of this together on the graph. We have vertical asymptotes at 2 and negative 2, and then the x-axis. So 2 is a vertical asymptote and negative 2 is a vertical asymptote. We also have that the x-axis is the horizontal asymptote. And we know that the origin is the x and y intercept. But that's really all the points we have from the information that we just found. If we wanted to algebraically find more points, we would have to individually plug in some points. So plug in negative 1 to the function, see what it spits out. Plug in positive 1 to the function and see what it returns, and so on. We would also do that to the right and to the left of those asymptotes. Let's use the calculator to figure out where those values are. So ny equals, we'll type in the function. Alpha y equals will give us the fraction look. In the top we have negative 3x, and in the denominator we have x squared minus 4. So we'll check out what that graph looks like. And in the middle we can see that it is definitely going through the origin, and we do have some asymptotes around that part in the middle. And then we have stuff on the left and the right side as well. If we wanted to get an approximation, we could use the trace key and get an approximate point. So roughly 2.53, again, or negative 2.53. Very, very rough estimate. We'll use that to get a quick sketch. And same thing on the right side, we'll use that trace key and go over to the right and find a point. So we'll try to find the same one. Yeah, so we have 2.5, negative 3. Again, very rough estimates there. We're just going for a quick sketch. Most of what will be tested on is the algebraic steps from earlier, finding the domain, asymptotes, and intercepts.